40 Most Amazing Things Seen by Galileo Spacecraft. Hello everyone, welcome to Space Explorer channel. The Galileo spacecraft, launched in 1989, was the first mission to study the planet Jupiter and its moons up close. During its 14-year mission, Galileo made numerous discoveries and captured stunning images of Jupiter and its 4 largest moons. We'll take a look at the 40 most amazing things seen by the Galileo spacecraft during its 33-minute observation of Jupiter and its moons. Before moving forward, if you are new to our channel, please don't forget to like and subscribe our channel for future interesting videos. 1. Jupiter's Great Red Spot. Jupiter's Great Red Spot is one of the most iconic and recognizable features in our solar system. This massive storm has been raging for centuries, and the Galileo spacecraft provided some of the clearest and most detailed images ever captured of the spot. The images revealed intricate details of the swirling clouds and turbulence within the storm, providing valuable insight into the dynamics of Jupiter's atmosphere. 2. Io's volcanic activity. Io, one of Jupiter's 4 largest moons, is the most geologically active object in our solar system. The Galileo spacecraft captured incredible images of the moon's numerous volcanic eruptions, some of which reached heights of up to 300 miles. These eruptions are fueled by the moon's proximity to Jupiter, which causes intense tidal forces that generate heat within Io's interior. As a result, Io's surface is constantly changing and evolving, with new volcanoes and lava flows forming regularly. Galileo also discovered that Io has a thin atmosphere of sulfur dioxide, which is produced by the volcanic activity and contributes to the moon's colorful appearance. The images and data captured by Galileo have greatly expanded our understanding of Io's dynamic geology and the complex interactions between moons and their parent planets in our solar system. 3. Europa's subsurface ocean. The Galileo spacecraft discovered that Europa, one of Jupiter's largest moons, has a subsurface ocean that may contain more than twice the amount of water found on Earth. This discovery was made by measuring the moon's magnetic field, which fluctuates as it interacts with Jupiter's powerful magnetic field. These fluctuations suggested the presence of a conductive fluid, such as a salty ocean, beneath Europa's icy surface. Follow-up observations by Galileo provided additional evidence for the ocean, including images of cracks and fractures in the ice that suggest it is actively shifting and moving. 4. Ganymede's magnetic field. Ganymede, Jupiter's largest moon, has its own magnetic field, which was discovered by the Galileo spacecraft. This finding was surprising because Ganymede was previously thought to be too small and cold to generate its own magnetic field. The discovery has led scientists to revise their understanding of how planetary magnetic fields are generated and maintained. Ganymede's magnetic field is also unique because it interacts with Jupiter's powerful magnetic field in a way that creates intense auroras around the moon's poles. 5. Callisto's ancient surface. Callisto, Jupiter's 3rd largest moon, has an ancient and heavily cratered surface that provides important clues about the history of the solar system. The Galileo spacecraft captured detailed images of the moon's surface, revealing a terrain that is more than 4 billion years old and largely unchanged since its formation. The images also showed evidence of geological activity, including tectonic faults and the formation of large impact basins. Callisto's surface is also notable for its dark and reddish coloration, which is likely due to a mixture of sulfur and carbon-based compounds. The data collected by Galileo has helped scientists understand the formation and evolution of the outer solar system. 6. Io's sulfur plumes. The Galileo spacecraft captured stunning images of sulfur plumes erupting from Io's volcanic vents. These plumes can reach heights of up to 190 miles and are made up of sulfur dioxide gas and various other chemicals. The plumes create a beautiful and otherworldly display, with bright yellow and orange colors that stand out against the blackness of space. The plumes also have important scientific implications, as they provide insight into the composition and dynamics of Io's atmosphere. 7. Europa's ice rafts. The Galileo spacecraft provided the first detailed images of the surface of Europa, one of Jupiter's largest moons. Among the most fascinating features are the ice rafts, large chunks of ice that have broken away from the moon's surface and moved around like puzzle pieces. The rafts can be as large as 12 miles across and are thought to be the result of the moon's icy surface being broken up and reassembled by tectonic forces. 8. Jupiter's magnetosphere. The Galileo spacecraft also provided important insights into Jupiter's magnetosphere, the region of space around the planet that is dominated by its magnetic field. Galileo's data showed that Jupiter's magnetosphere is the largest structure in the solar system, extending more than 600 million miles from the planet. The magnetosphere is also incredibly dynamic. 9. Ganymede surface composition. The Galileo spacecraft captured detailed images of Ganymede's surface, revealing a complex terrain of craters, mountains, and valleys. The moon's surface composition is also of interest, as it appears to contain a mixture of rock and ice. The images and data provided by Galileo have greatly expanded our knowledge of Ganymede and its fascinating geological properties. In addition, Galileo's observations of Ganymede's magnetic field have challenged previous assumptions about the moon's ability to generate its own magnetic field. The discovery has led to a better understanding of how magnetic fields are generated and maintained on planetary bodies. The data and images collected by Galileo have also helped scientists understand the formation and evolution of the outer solar system. 10. Io's tidal heating. Io, one of Jupiter's largest moons, is the most geologically active object in our solar system. This is due to its proximity to Jupiter, which generates intense tidal forces that create heat within Io's interior. The heat causes the moon's surface to constantly change and evolve, with new volcanoes and lava flows forming regularly. The Galileo spacecraft captured incredible images of Io's numerous volcanic eruptions, some of which reached heights of up to 300 miles. 11. Europa's chaos terrain. Europa, one of Jupiter's largest moons, is known for its fascinating and unusual surface features. One of the most interesting discoveries made by the Galileo spacecraft was the chaos terrain on Europa. These areas are characterized by jumbled and broken ice blocks, with no discernible pattern or structure. Scientists believe that these areas may be the result of subsurface activity, such as the melting and refreezing of the moon's icy crust. Alternatively, it is possible that they are the result of impact events. Whatever the cause, the chaos terrain on Europa is a unique and fascinating feature that has captured the imaginations of scientists and the public alike. 12. Jupiter's polar regions. The Galileo spacecraft also provided us with a unique view of Jupiter's polar regions. These areas are marked by stunning auroras, similar to those seen on Earth, but on a much larger scale. The auroras on Jupiter are caused by the interaction between the planet's strong magnetic field and charged particles from the solar wind. Galileo's observations of these auroras helped us better understand the structure and behavior of Jupiter's magnetic field. 13. Io's lava lakes. Io, one of Jupiter's moons, is the most volcanically active body in our solar system. Thanks to the Galileo spacecraft, we now know that Io has hundreds of active volcanoes, with some erupting continuously for decades. The spacecraft also discovered lava lakes on Io, which are large pools of molten rock that can span several kilometers in diameter. These lakes are incredibly hot, with temperatures reaching up to 2,000 degrees Fahrenheit. Studying these lava lakes has provided insights into the geology and chemistry of Io's surface and how it has evolved over time. The discovery of Io's volcanic activity has also helped us better understand the processes that shape the surfaces of other planets and moons in the solar system. The images and data collected by the Galileo spacecraft have given us a new appreciation for the extreme and dynamic environments that exist in our solar system. 14. Europas Geysers. Europas Geysers are one of the most fascinating discoveries made by the Galileo spacecraft. These plumes of water vapor and ice particles erupt from the Moon's surface, reaching heights of up to 125 miles. The geysers on Europa are thought to be caused by a subsurface ocean, which may contain more than twice the amount of water found on Earth. The Galileo spacecraft detected evidence of these geysers during several flybys of Europa, providing scientists with valuable insights into the Moon's interior. Studying these geysers can help us understand the potential habitability of Europa. 15. Ganymedes tectonic activity. The Galileo spacecraft also revealed that Ganymede, another of Jupiter's moons, has tectonic activity. This means that the Moon's crust is constantly shifting and moving, similar to the way tectonic plates on Earth move. This is the first time such activity has been observed on a moon in our solar system. Ganymedes tectonic activity is likely caused by the gravitational forces exerted by Jupiter and the other moons in the system. The Galileo spacecraft's observations of Ganymedes tectonic activity. 16. Eos plume. The plume on Io is another incredible discovery made by the Galileo spacecraft. It is a towering volcanic eruption that can reach heights of up to 300 miles, making it one of the largest volcanic eruptions in our solar system. The plume is named after Pele, the Hawaiian goddess of fire and volcanoes. The eruption is caused by the intense heat and pressure generated by the molten rock beneath Io's surface. Studying the Pele plume has provided insights into the extreme and dynamic environment of Io and has helped us better understand the geological processes that shape the surfaces of other planets and moons in the solar system. 17. Europa's surface chemistry. The Galileo spacecraft also provided us with valuable insights into the surface chemistry of Europa, one of Jupiter's moons. The spacecraft detected the presence of salts on Europa's surface, including magnesium sulfate and sodium chloride. These salts are thought to have been brought to the surface by the subsurface ocean, which is believed to be in contact with the Moon's rocky mantle. The detection of these salts has important implications for the potential habitability of Europa, as they could provide a source of nutrients and energy for microbial life. The Galileo spacecraft's observations of Europa's surface chemistry have also helped us better understand the processes that shape the surfaces of other moons and planets in the solar system. The discovery of salts on Europa is just one example of the many incredible things seen by the Galileo spacecraft that continue to inform and inspire our exploration of the universe. 18. Jupiter's lightning. Jupiter's lightning is one of the most stunning phenomena seen by the Galileo spacecraft. The lightning on Jupiter is far more powerful than the lightning on Earth and can be seen for thousands of miles. Galileo's observations of the lightning helped us better understand the structure and behavior of Jupiter's atmosphere. The spacecraft also detected powerful radio signals associated with the lightning, which can be used to study the planet's magnetic field and interior. 19. Io's atmosphere. The Galileo spacecraft discovered that Io, one of Jupiter's moons, has an atmosphere, a rare occurrence among the moons in our solar system. Io's atmosphere is primarily composed of sulfur dioxide, which is released by the many active volcanoes on the Moon's surface. The atmosphere is also thought to contain other gases, such as sulfur monoxide and atomic sulfur, which can be detected using infrared instruments. Studying Io's atmosphere has provided valuable insights into the volcanic activity on the Moon and how it affects the surrounding environment. The Galileo spacecraft's observations of Io's atmosphere have also helped us better understand the chemical and physical processes that occur on other moons and planets in our solar system. The discoveries made by the Galileo spacecraft continue to broaden our understanding of the universe and inspire us to explore the mysteries that lie beyond. 20. Europa's brine pockets. The Galileo spacecraft also discovered pockets of briny water on Europa's surface. These pockets are thought to be connected to the subsurface ocean and are a potential location for life to exist. The briny water may contain nutrients and organic materials that could support microbial life. Studying these pockets has provided valuable insights into the potential habitability of Europa and how it compares to other moons and planets in the solar system. The Galileo spacecraft's observations of Europa's brine pockets have also helped us better understand the geological processes that shape the surfaces of moons and planets. The discovery of brine pockets on Europa is just one example of the many incredible things seen by the Galileo spacecraft that continue to inform and inspire our exploration of the universe. 21. Jupiter's auroras. Jupiter's auroras are some of the most spectacular in the solar system, and the Galileo spacecraft was able to capture incredible images of these events. The auroras are created by charged particles from the solar wind interacting with Jupiter's magnetic field, which causes them to spiral towards the poles. As they do so, they collide with the molecules in the planet's atmosphere, releasing energy in the form of light. 22. Eos Plasmus. The Galileo spacecraft captured stunning images of Eos Plasmus, one of the largest volcanic features in the solar system. This volcanic caldera is constantly changing, with periodic eruptions causing the floor of the crater to rise and fall by as much as 100 meters. The Galileo spacecraft's observations revealed that the eruptions are caused by a combination of thermal expansion and the release of gas from molten magma beneath the surface. The images also showed that the lava lake in the center of the crater is constantly overturning, creating a chaotic pattern of flows and eddies. These observations have provided valuable insights into the dynamics of volcanic activity on Io, which is the most volcanically active object in the solar system. 23. Europa's ice thickness. The Galileo spacecraft made a number of observations that shed light on the thickness of the ice layer on Europa's surface. The spacecraft's magnetometer detected that the magnetic field of Jupiter varies as Europa moves through it, indicating that the moon's interior is not solid, but rather has a subsurface layer of electrically conductive material, such as salty water. The spacecraft also observed bright and dark areas on Europa's surface, indicating that the ice layer may be relatively thin in some places, revealing the ocean underneath. This data has been used by scientists to estimate the thickness of Europa's ice layer, which is believed to be around 10 to 30 kilometers. Understanding the thickness of the ice layer is crucial to understanding the potential habitability of Europa's ocean, which is thought to contain more than twice the amount of water in Earth's oceans. 24. Jupiter's Magnetodisk. The Galileo spacecraft also captured fascinating images of Jupiter's Magnetodisk, a vast region of charged particles that surrounds the planet. This region is created by the interaction between Jupiter's magnetic field and the solar wind, which causes the charged particles to be trapped in the magnetosphere and to form a disk-like structure. The Galileo spacecraft's observations allowed scientists to study the dynamics of this magnetodisk in unprecedented detail, revealing complex patterns of plasma flow and magnetic fields. 25. Eo's volcanic plumes. Io, one of Jupiter's largest moons, is the most volcanically active body in the solar system. The Galileo spacecraft captured amazing images of the plumes of volcanic material erupting from Io's surface, some of which reached heights of over 300 kilometers. These plumes are created by a combination of gas and dust erupting from the volcanoes on the surface, which is then ionized by the high-energy radiation surrounding Jupiter. The plumes can be seen in both visible and ultraviolet light, revealing their complex and ever-changing nature. 26. Europa's subsurface channels. The Galileo spacecraft also revealed the presence of subsurface channels on Europa, suggesting that the Moon has a complex system of underground waterways. These channels were identified using a combination of gravity and magnetic field data, which revealed irregularities in the Moon's surface that could be explained by the presence of subsurface channels. These channels are believed to be caused by the movement of water beneath the Moon's icy surface, possibly driven by the tidal forces exerted by Jupiter. The discovery of these subsurface channels has raised exciting possibilities for the potential habitability of Europa's ocean, as they could provide a means for nutrients and energy to circulate through the Moon's subsurface environment. Understanding the dynamics of these channels is an ongoing area of research for planetary scientists studying the outer solar system. 27. Jupiter's Io Plasma Taurus. The Galileo spacecraft's observations of Jupiter's Magnetodisk also revealed the existence of the Io Plasma Taurus, a donut-shaped ring of charged particles surrounding the planet. This plasma torus is created by the interaction between Jupiter's magnetic field and the volcanoes on Io's surface, which ejects large amounts of gas and dust into space. The charged particles in the plasma torus can be seen in ultraviolet light, where they create a bright and dynamic display. 28. Europa's Volcanism. The Galileo spacecraft's observations of Europa also revealed evidence of cryovolcanism on the Moon's surface. Cryovolcanism, or cold volcanism, involves the eruption of icy materials rather than molten rock. The Galileo spacecraft's observations showed that there are areas on Europa's surface that have been resurfaced relatively recently, suggesting that cryovolcanic activity is still occurring. This activity is believed to be driven by the tidal forces exerted by Jupiter on Europa's surface, which cause the Moon's interior to heat up and melt some of the ice on its surface. The resulting cryovolcanic eruptions could provide a mechanism for transporting material from the subsurface ocean to the surface, where it could be studied by future missions. 29. Ganam Surface Age. The Galileo spacecraft also provided valuable insights into the surface age of Ganymede, the largest moon of Jupiter and the largest moon in the solar system. The spacecraft's observations showed that the Moon's surface is relatively young, with most of the craters and other features believed to be less than 1 billion years old. This suggests that the Moon has been geologically active in recent history, possibly due to the tidal forces exerted by Jupiter and other moons in the system. 30. Eos Ionosphere. The Galileo spacecraft's observations of Io's ionosphere revealed fascinating insights into the Moon's interaction with Jupiter's magnetic field. Eos ionosphere is created by the interaction between the charged particles in Jupiter's magnetosphere and the gases in Io's atmosphere. The Galileo spacecraft's observations showed that the ionosphere is highly dynamic, with changes occurring over timescales of minutes to hours. The spacecraft's data also revealed that Io's ionosphere is affected by the volcanoes on the Moon's surface, which release large amounts of gas and dust into space. This material can interact with the charged particles in Jupiter's magnetosphere, creating fascinating displays of auroras and other electromagnetic phenomena. The Galileo spacecraft's observations of Io's ionosphere have provided important insights into the complex interactions between moons and planets in the outer solar system, and have helped to advance our understanding of the broader processes that shape the behavior of the solar system. 31. Europa's impact craters. Europa, one of Jupiter's largest moons, is known for its icy surface and potential for hosting extraterrestrial life. The Galileo spacecraft provided high-resolution images of the Moon's surface, revealing the presence of numerous impact craters. These craters are believed to have been caused by asteroids or comets colliding with the Moon's surface. Some of the larger craters have central peaks, indicating that they may have been formed by a powerful impact. 32. Jupiter's zonal winds. Jupiter's zonal winds are another fascinating feature that the Galileo spacecraft was able to capture. These winds blow in alternating east-west directions, with speeds reaching up to 650 kilometers/hour. The spacecraft's data revealed that these winds extend deep into the planet's atmosphere, with the most intense winds occurring near the equator. Scientists have also observed that the winds vary in speed and direction over time, indicating that they are not static. 33. Eos Plasmus Interaction. The Galileo spacecraft also captured stunning images of the volcanic moon Io, revealing its interaction with Jupiter's magnetosphere and the formation of a plasma torus. The torus is a donut-shaped cloud of charged particles that encircles Jupiter and interacts with Io's volcanic activity. The spacecraft's data showed that the plasma torus is made up of ionized sulfur and oxygen particles that originate from Io's volcanic eruptions. The torus also has a complex structure with different regions of plasma that rotate at different speeds. 34. Europa's surface temperature. The Galileo spacecraft also provided information on Europa's surface temperature, which is believed to be a key factor in the Moon's potential habitability. The spacecraft's data revealed that Europa's surface temperature varies greatly, with the warmest areas reaching around -160 degrees Celsius and the coldest areas dropping to -220 degrees Celsius. These temperature variations are thought to be caused by the Moon's eccentric orbit around Jupiter and its interaction with the planet's strong gravitational field. The study of Europa's surface temperature has helped scientists understand the Moon's geology and its potential for hosting life, by identifying areas where temperatures are more moderate. 35. Ganymede's subsurface ocean. The Galileo spacecraft also provided insights into Ganymede, Jupiter's largest moon, and its subsurface ocean. The spacecraft's data showed evidence of a salty ocean beneath the moon's icy surface, with the ocean believed to be 800 kilometers deep. Scientists also observed that the ocean interacts with Ganymede's magnetic field, which creates auroras on the moon's surface. The discovery of a subsurface ocean on Ganymede has sparked interest in future missions to the moon, as it could potentially host extraterrestrial life. The Galileo mission's study of Ganymede has greatly expanded our understanding of the outer solar system and the potential for habitable environments beyond Earth. 36. Io's lava flows. Io, one of Jupiter's 4 Galilean moons, is the most volcanically active body in the solar system. The Galileo spacecraft captured stunning images of Io's lava flows, revealing the extent and intensity of the moon's volcanic activity. The images showed that the lava flows can cover hundreds of square kilometers and reach temperatures of up to 1,200 degrees Celsius. The spacecraft's data also revealed that Io's volcanic activity is driven by the moon's proximity to Jupiter and the planet's gravitational influence. 37. Europa's surface composition. The Galileo spacecraft also provided information on Europa's surface composition, revealing that the moon's surface is primarily composed of water ice. However, the spacecraft's data also showed the presence of other materials, including sulfur and magnesium compounds. These compounds are thought to have been brought to the moon's surface by volcanic activity or impact events. The study of Europa's surface composition has provided insight into the moon's geological history and the processes that have shaped its surface. Additionally, it has informed our understanding of the potential for habitable environments on the moon, as the presence of certain compounds could provide energy sources for microbial life. The Galileo mission's discoveries continue to expand our knowledge of the universe and the possibilities for life beyond our planet. 38. Jupiter's ring system. The Galileo spacecraft also provided valuable insights into Jupiter's ring system, which had previously only been observed by ground-based telescopes. The spacecraft's data revealed that Jupiter has 4 main rings, which are made up of small particles of rock and dust. The innermost ring is the halo, followed by the main ring, the Amalthea-Gossamer ring, and the Thebe-Gossamer ring. The rings are thought to have formed from the breakup of small moons or the debris from comets and asteroids. The study of Jupiter's ring system has helped us understand the dynamics of the outer solar system and the processes that shape planetary systems. Additionally, it has provided insight into the origins of the solar system and the evolution of planetary rings. The Galileo mission's discoveries continue to inspire and inform our understanding of the universe around us. 39. Eos surface topography. The Galileo spacecraft's observations of Io's surface topography reveal the world of contrasting features. The Moon's surface is marked by mountains, valleys, and plains, with some regions covered in dark, volcanic material and others showing bright, icy deposits. The spacecraft's data also revealed evidence of tectonic activity on the Moon's surface, including large, blocky mountains and narrow rift valleys. These features suggest that Io's interior is still geologically active, with ongoing volcanic eruptions and crustal deformation. The study of Io's surface topography has provided insight into the processes that shape the Moon's surface and the role of Jupiter's gravity in shaping the satellite's geology. Additionally, it has inspired research into the potential for similar geological activity on other moons and planets in our solar system and beyond. The Galileo mission's discoveries continue to expand our knowledge of the universe and the forces that shape it. 40. Europa's tidal flexing. The Galileo spacecraft's observations also shed light on Europa's tidal flexing. Europa's eccentric orbit around Jupiter causes the Moon to experience gravitational forces that cause it to bulge and contract. This tidal flexing generates heat, which could potentially sustain a subsurface ocean and create habitable environments. The Galileo spacecraft detected evidence of this heat through its magnetic field measurements, which revealed that Europa's ocean may be in contact with its rocky mantle. This interaction could create chemical gradients and energy sources that could support life. The study of Europa's tidal flexing has opened up new avenues for understanding the potential for life beyond Earth and has inspired future missions to explore the Moon's subsurface ocean. If you enjoyed from this video, please don't forget to like and subscribe our channel for future interesting videos. Thanks for watching.